Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight's assignment is from Math 1, Worksheet 3.3b. Remember that the homework help mirrors the problems exactly on your homework. So they're very, very similar problems, and if you have trouble with one problem on the homework, fast forward to that number here, and our problem will be so close that you should be able to figure out your homework problem. So let's get started. In problem 1, we're asked, first of all, on the graph below to graph and label these three functions. Let's start with the first one. The first one is f of x, and it says that f of x equals 2x. Well, looking at that, I can see immediately that my slope equals 2, and my y-intercept is 0. So I can start with my y-intercept and know that this line is going through the origin. It has a slope of 2, so I can count up 2. 1, 2, and over 1, and there's another point. I can continue up 2 and over 1, up 2 and over 1, and even go backwards, down 2 and back 1. And that can help me draw my lines since I don't have a ruler here that'll work on my computer. So there's my first point, and that is f of x. My second line, g of x, is 2x plus 3. Notice here that my slope is again 2, but my y-intercept now is 3. So I start at the origin and go up 1, 2, 3. There's my first point, my y-intercept. And now again, the slope is 2, so it's up 2 over 1 for that point. And if I go backwards, it's here. Backwards, it's here. Down 2, back 1, down 2, back 1. And so this graph looks something like this. And this is the graph g of x. I put a label there by it. And then my third one is h of x. And h of x equals 2x minus 4. So this time my slope is the same, minus 2. And b now is minus 4. So starting at 0, we go down 4. 1, 2, 3, 4. And at this point then, same slope. So up 2 over 1. Up 2 over 1, up 2 over 1, and even backwards here. And so this is our graph for h of x. So let me label this h of x. Okay. So there's our three lines. Okay. Name two things these lines have in common. Well, they are all linear. In other words, they are all straight lines. Second, they have the same slope. M equals 2, which implies they're all parallel lines. What's different about them? Well, they each have a different y-intercept. Where do they cross the y-axis? Red one crosses at 0, the other one crosses at 3 and minus 4. And they also have, even though it's not listed in our formula, they also cross the x-axis at different places. So if I ask for my x-intercept, notice this one crosses at 2, this one at 0, this one at like 1.5, negative 1.5. So different intercepts there. What could you do to graph to go from the green one, the red one, to the blue one? Well, notice what you can do here is in every point, just translate up 3. It's 2x plus 3. So I can translate f of x up 3 units. Similarly, what can I do to go from f of x to h of x? Notice here I would just go down 4 units. So I would translate f of x down 4 units. Key thing to notice is when they all have the same 2x, 2x, 2x. When I add 3, everything just goes up 3. When I subtract 4, every point goes down 4. Problem 2 gives us two equations, f of x equals negative 1/3 x, and g of x, which equals negative 1/3 x plus 2. In part A, it says graph f of x and then g of x by shifting f of x. So let's graph f of x first. So notice that if f of x equals minus 1/3 x, that means that m equals minus 1/3 and b is 0. So I get my 0. And now the slope is minus 1/3, which means go down 1 and over 3. And so that's a point. Down 1 and over 3. And I can go backwards 3 and up 1. Backwards 3 and up 1. So there's my f of x. Now it says, do this by shifting. Well, shifting, I'm going to go up 2, plus 2. So what I'm going to do here is I'm just going to go up here and go up 2. Every place I'm going to go up 2. Up 2. Here I go up 2. Here I go up 2. Here I go up 2. And here I go up 2. And that's my next line. I got off there somehow. Where did I get off? There we go. That's a better line. Sorry, guys. So that's my line by just shifting everything plus 2. The next thing it asks me to do in B is to graph g of x by stating the line, the slope, and the y-intercept. Well, g of x equals minus 1/3 x plus 2, which implies that the slope equals minus 1/3, but the y-intercept is 2. So in this case, I would come here and go up 2, and then I would come down 1 over 3, down 1 over 3, back 3 and up 1, back 3 and up 1, and then graph it this way. Okay. So my slope here is minus 1/3 if you're filling this out, and my y-intercept is 2, which is the point 0, 2. And then I compare these and notice what's the similarity? They are the same. So whether I use this to graph it, the y-intercept and the slope, or whether I just take this and shift it up, I'm going to get the same result. Okay? So the lines are the same. Now problem 3 is a little bit like problem 1. In problem 1, we had the same x term, but the y-intercept kept changing. In this term, you notice that the y-intercept is the same, 1. It's the slope that keeps changing. Okay? So first it says to graph them. So let's go. F of x equals x plus 1. That implies that my slope equals 1. It's 1x. And my y-intercept is 1 as well. So I come here, my y-intercept's 1, so up 1, and we're going to go right there. And my slope is 1. So it's just up 1 over 1, up 1 over 1. And so we can kind of put those dots to keep us lined up. And then there is our line. So there is f of x. Okay? Our next one, g of x. G of x equals 1/2 x plus 1. So my slope now is 1/2, but my b remains the same. So when I'm graphing that, I'm going to start at the same point, but this time my slope is up 1 and over 2. So I'm going to go up 1 and over 2, up 1 over 2, up 1 over 2 here, and then down 1, back 2, down 1, back 2, and back 2. And so now it goes to the same point, but it looks something like that. So that is my g of x. And then my h of x, again, is the slope changes, so it's 2x plus 1. So the slope is now 2, and the b is the same. So again, they're all going to start at the same point. This time the slope is 2, so I go up 2 and over 1, up 2 and over 1, and likewise back 2 over 1. And so my line looks something like this. And that is my h of x. Now the questions. Name 2 things these functions have in common and why. Okay. First of all, they're all linear again. That is, they're all straight lines. They have an x term. And this one, they have the same y-intercept. They all have an intercept of b equals 1. What's different about them? And what's different about them is they have a different slope, which defines their steepness, you might say, how steep the line is, okay? And then at the same time, you will notice that they end up with different x-intercepts. Because of the different slope, where they cross the x-axis is at different points. Now, what could you do to x in number c? What can you do to f of x equals x plus 1 to graph 1/2 plus x? Well, the answer is you change the slope, and 1/2 is less than 1, so you make it less steep. If I can write here at all. In other words, I'm taking the red, and imagine the red is stuck right on the y-intercept, but you rotate it down somewhat. On the next one, how do you change 2x plus 1? Again, you're changing the slope, and you're going to make it more steep or rotate up. So in this case, changing the slope is rotating the line either up or down on the y. Notice the y-intercept stays the same here, and you're just rotating the line based upon what the slope is. Problem 4 has to do with the absolute value function. First of all, f of x equals the absolute value of x. Remember that absolute value is a distance. It's always, always, always positive. So for example, the absolute value of -2, how far is -2 from 0? If you look at a number line, it's +2. The absolute value of -1 is +1. The absolute value of 0, it's on 0, so it's 0. The absolute value of 1, of +1, is 1 again. And the absolute value of 2 is 2. The thing to notice is that the absolute value is always a positive number. So if I graph these, notice I'm going to have -2, 2. I'm going to have -1, 1, 0, 0, and then 1, 1, and 2, 2. And so what we have is that traditional V-shaped absolute value. Okay. Now the next thing says, how do I graph wx plus gx plus 2? Well, very simple. What I'm going to do for g of x is I'm simply going to translate f of x up 2 units. So at every point here, I'm going to go up 2. So notice if I go up 2 on all these, I'm going to end up with a graph that looks something like this. On the same hand, the next one says absolute value -3. So for h of x, we're going to translate f of x down, because it's -3 units. So I come here and I go down 3, but then I get the same exact graph going this way. So you're just taking the graph and either moving it up or moving it down. This is when you add something outside the absolute value function. Okay? Again, it's outside. So if I were making a table, for example, here for h of x, I have, this is x, and this is the absolute value of x minus 3, absolute value here. Let me erase that and start over so I don't confuse you. Let's go with g of x first. So y is here, x is here, and g of x is absolute value of x plus 2. So notice I have -2, -1, 0, 1, 2. And here I would have the absolute value of -2 plus 2. Well, the absolute value of -2 is 2, so you get 2 plus 2 is 4. The absolute value of -1 is +1 plus 2 is 3. The absolute value of 0 is 0 plus 2, and you get 2. And then absolute value of 1 is 1 plus 2 is 3. Notice we're going back up. And the absolute value of 2 plus 2 is 4. See how we have that similar thing where it rotates around, starts at 2 and goes up in both directions. Likewise, the same thing happens if I'm doing h of x, and here I have h, and now I have the absolute value of h minus 3. So in this case, if I have minus 2, minus 1, 0, 1, and 2 as my x values, I have the absolute value of minus 2, which becomes positive 2, but 2 minus 3 is negative 1. The absolute value of minus 1 minus 3 becomes minus 1 is 1, minus 3 becomes minus 2, and the absolute value of 0 is 0, minus 3 is minus 3. And now we go back here, minus 1, the absolute value of positive 1 is 1, and 1 minus 3 is minus 2, and then absolute value 2 minus 3 is minus 1. Notice that same pattern. We have the pairing like that. It's everything's just dropped down 3 units. Problem 5 says, with no graphing utility, graph and label the following functions. Notice my first one is f of x equals absolute value of x. We remember this one is right at 0, and it's just a perfect V shape out of here. Okay. Now the question here is, what happens when I put the 2 in the inside? See, if I added it outside, like absolute value of x then plus 2, we would know we would move up or down, but what happens here? And the way I usually do that is I ask myself the question, what value of x does x plus 2 equal 0? And notice that if I subtract 2, I find out it's x equal minus 2. So what I'm going to do here for g of x is I'm going to come over to minus 2, go over here to 2, and then at this point I draw the exact same graph at that point. Okay? And if you were to draw a little table here and put these numbers in here, you would see that you would get this graph here. On the other hand, if I look at h, it says when is x minus 3 equals 0? Well, I'll add 3, and that's at x equal 3. So I'm going to come over here from 0, 1, 2, 3, and now I draw the same graph there. So it's a little counterintuitive, but you can see that if I were to write this down here, that g of x translates 2 to the left, and h of x translates 3 to the right. Gets a little confusing at times because students are tempted to go, oh, plus 2, I must go to the right 2. Oh, minus 3, I must go to the left, but it's actually the opposite. Think in terms of when does x plus 2 equal 0? That's minus 2. When does x minus 3 equal 0? That's plus 3. And that may help you get the shift going on there. In the second one, notice what they've done. They've done 2 things here for g of x. So first of all, let's plot our f of x equals absolute value of x. That's this simple v coming up here. And they want to know what happens if I have absolute value of x plus 1 plus 3. Well, the plus 3 means it's going to translate up plus 3. Okay? The x plus 1, notice that when does x plus 1 equal 0? When x equals minus 1. So this is going to cause it to go back left 1. Okay? So to to plot g of x, I'm going to go up 3, 1, 2, 3, and over 1. That's the vertex of my maximum here. And there's going to be my graph right there. Now in the next one, once again on C, let's graph the f of x in red. And then it says, in this case, notice that when does x minus 3 equal 0? When x equals 3. So this means I'm going to go to the right 3. This means I'm going to go down 2. So if I come over here to my graph, first I'm going to go to the right 3, 1, 2, 3, and then I'm going to go down 2. So my vertex is going to be there, and my graph will look something like this. Okay? So just remember, especially when the number is outside, like the 3, you're just going up or you're going down. When it's inside the brackets, you're translating right or left, and it's kind of counterintuitive. Think, when will that equal 0? And that should help. Problem 6 gives us a function, the graph of f equals x squared, a quadratic, and it asks us to sketch, what do we think x squared minus 2 equals? Well, from our experience, we should realize all that's going to happen is that every point's going to come down 2 points. Everything's going to come down 2 points. So if it starts here, it's going to come down to there, and so I can sort of sketch this by going down 2 and then sketching my u in there. Not a very good u, but it'll pass for today. Our last problem, number 7, is just like the one before. They give us a sketch here, and they want us to know if this is f of x here, which is actually an interesting equation. It's actually a cubic function. But they want to know what happens if I add 3 to it. Well, the answer is everything goes up 3. Okay? Every point goes up 3. So notice here is at 1. This looks like about right here, and it's going to go up 1, 2, 3. So it's going to have a point there. The 0 point is actually going to be, well, the 0 point is going to be at 3. So this is going to be a little higher than 3. It's going to be more like there. And then this point, which is at 2, is going to be up here at 1. So I'm going to have a graph looking like that. And from this point, it's coming down, and it kind of connects like that. But at each point, we went up 3. Okay? I hope that helps you with your homework. See you in class.